Have you ever wondered how the space race began? From the Cold War tensions to historic moments of unity in space? Delve into the saga of space exploration. Journey from Soyuz to Apollo, from Sputnik to the ISS. Unravel the mysteries of the space race, recalling the tragedies and triumphs on the road to the stars. Experience with us the first handshakes in open space and the plunge into the boundless expanses of the universe. Welcome to the thrilling voyage, the complete history of space exploration. It all started in the aftermath of World War II. The world was divided into two major power blocks, the United States on one side and the Soviet Union on the other. This division marked the beginning of the Cold War, a time of political and military tension that lasted for more than 4 decades. But it wasn't just a battle of ideologies, it was also a race for technological supremacy. As the dust of World War II settled, both superpowers scrambled to recruit German scientists, many of whom had worked on the notorious V-2 rocket program. These brilliant minds, now scattered across the globe, became the driving force behind the burgeoning space programs of both nations. In the United States, under the guidance of former German scientist Wernher von Braun, the National Aeronautics and Space Administration, or NASA, was established. Its mission, to pioneer the future in space exploration, scientific discovery, and aeronautics research. Meanwhile, on the other side of the Iron Curtain, the Soviet Union was also making strides. The Soviets, under the leadership of chief designer Sergei Korolev, formed their own space program. Their goal was the same, yet different. They too sought to conquer the final frontier, but their journey was fueled by a desire to demonstrate the superiority of the Soviet system. The stage was set. 2 superpowers, 2 ideologies, 2 dreams of reaching the stars. Each side was armed with the technology they had inherited from the war, and the German scientists they had recruited. They were ready to compete, not on the battlefield, but in the vast, uncharted territories of space. Thus, the stage was set for an unprecedented contest between 2 superpowers, a race not on the battleground, but in the uncharted territories of space. The year 1957 marked a significant turning point in human history, the birth of the space age. This was the year that saw the launch of Sputnik by the Soviet Union, the world's first artificial satellite. A sphere of metal, measuring just over 23 inches in diameter and weighing no more than 184 pounds. It might seem simple by today's standards, but Sputnik's launch was anything but ordinary. This little satellite, with its polished metal surface reflecting sunlight, was visible from the Earth, and its radio signals were detectable even by amateur radio operators. The world watched and listened in awe as Sputnik orbited our planet, a beacon of technological achievement that signified humanity's first step into the vast expanse of space. The launch of Sputnik was a shock to the rest of the world, a clear demonstration of the Soviet Union's technological prowess. It was a wake-up call, a realization that the race for space was not just a theoretical pursuit, but a reality. The Soviets had taken the lead, sending a powerful message to the United States and the rest of the world. The successful launch of Sputnik spurred an unprecedented acceleration of efforts in the United States. The space race was no longer a slow, methodical progression of technological advancements. It was a sprint, a competition fueled by national pride and the desire for supremacy. The world was captivated by the audacity of this achievement. The launch of Sputnik sparked a sense of wonder, fear, and excitement. It marked the beginning of a new era, an era characterized by rapid advancements in technology, exploration, and understanding of the cosmos. Sputnik's successful launch sent ripples across the world, and the space race was truly on. This momentous event symbolized the beginning of the space age, and the subsequent years would see humanity reach further into the cosmos, achieving feats previously thought impossible. Space exploration was not without its milestones and challenges. The year 1961 marked an age of firsts in space exploration. A young Soviet pilot, Yuri Gagarin, was catapulted into the annals of history, becoming the first human to leave the confines of our planet and venture into the great unknown. Orbiting the Earth once in his spacecraft Vostok 1, His flight lasted a mere 108 minutes, but its impact was immeasurable, forever changing the way we perceive our place in the universe. The United States, not to be outdone, initiated the Mercury program, aiming to put an American astronaut into orbit. Alan Shepard would be the first American to experience the weightlessness of space, albeit in a suborbital flight. But it was John Glenn who would achieve the goal of the Mercury program, orbiting the Earth 3 times in his spacecraft, Friendship 7. Simultaneously, the Soviet Union was pressing on with its own Vostok program. Gagarin's pioneering flight was followed by a series of missions that pushed the boundaries of human endurance and technological capability. The Vostok missions not only put the first woman, Valentina Tereshkova, into space, but also set the record for the longest single flight by a human, clocking a staggering 4 days in orbit. Space exploration, though filled with thrilling successes, was also fraught with challenges. The harsh reality of space's unforgiving environment was never far from the minds of those brave pioneers. From the physical and psychological tolls of living in zero gravity to the technical difficulties of navigating uncharted territories, these early astronauts faced trials that tested the limits of human ingenuity and resilience. Yet, these challenges did not deter but fueled the quest for knowledge and discovery. Each hurdle overcome, each successful mission, was a step towards understanding the immense cosmos that lies beyond our world. These early missions laid the foundation for the future of space exploration. The journey to space was fraught with both triumphs and tragedies. The Space Shuttle program, initiated by NASA in the late 70s, was a beacon of hope and a testament to human ingenuity. It promised regular access to space with reusable shuttles that could carry large payloads and a crew, paving the way for unprecedented scientific exploration. However, the path to progress is often marred by setbacks. In January of 1986, the world watched in horror as the Challenger space shuttle disintegrated just 73 seconds into its flight, claiming the lives of all 7 crew members. A devastating blow. This tragedy was a stark reminder of the inherent risks involved in space travel. Despite the Challenger disaster, the Space Shuttle program continued, with successes that far outweighed the setbacks. The shuttles launched the Hubble Space Telescope, made numerous satellite deployments and repairs, and played a significant role in constructing the International Space Station. This was an era of triumph, with space shuttles becoming a symbol of human resilience and our insatiable thirst for knowledge. But triumph was once again followed by tragedy. In February of 2003, the Columbia Space Shuttle disintegrated upon re-entry into Earth's atmosphere, killing all 7 astronauts on board. This catastrophe led to a re-evaluation of the Space Shuttle program and ultimately its retirement in 2011. However, the legacy of the Space Shuttle program lives on. The lessons learned from the Challenger and Columbia disasters have led to advancements in safety measures, design improvements, and risk mitigation strategies in space exploration. These experiences have shaped the future of space travel, leading to safer, more reliable spacecraft. Our journey to the stars has not been easy, but it's a journey we continue to embark on, driven by our curiosity and our desire to push the boundaries of human potential. These events, both heartbreaking and triumphant, shaped the course of space exploration. In 1975, a historic event marked the beginning of a new era in space exploration. This was the year of the Apollo-Soyuz test project, a mission that signified a pivotal shift in space relations between the 2 superpowers of the time, the United States and the Soviet Union. For years, the 2 nations had been locked in a fierce space race, each striving to outdo the other in a bid for technological and ideological supremacy. Yet, rising from the ashes of this intense rivalry was a beacon of collaboration, a shared vision that transcended borders and political ideologies. On July 17, 1975, a U.S. Apollo spacecraft and a Soviet Soyuz spacecraft launched into space, each carrying a crew of astronauts and cosmonauts. 2 days later, they achieved something that had never been done before: a successful docking in space. This wasn't just a technological achievement, it was a symbolic meeting that marked the end of the space race. For 44 hours, the two crews lived and worked together, conducting joint scientific experiments and sharing meals. Language and cultural barriers were overcome, friendships were forged, and a message of peace was broadcast to the world. Following the Apollo-Soyuz mission, international cooperation became a cornerstone of space exploration. The mission laid the groundwork for future collaborations, such as the joint Shuttle Mir missions and the construction of the International Space Station, a multinational endeavor that continues to serve as a testament to what humanity can achieve when we work together. The Apollo-Soyuz mission was more than just a successful docking in space. It symbolized a thaw in the Cold War and a shift from competition to cooperation. It represented a realization that space, the final frontier, should be a realm of peace, collaboration, and shared discovery, rather than a battleground for national pride or military dominance. The Apollo-Soyuz mission symbolized a thaw in the Cold War and opened a new chapter of cooperation in space. It was a testament to the power of diplomacy, the potential of science, and the unifying force of shared goals. And it proved that even in the vast expanse of space, Greetings, space enthusiasts and history buffs. Welcome to our journey through time, starting from the very beginning when humans first looked up at the night sky. Long before telescopes and satellites, ancient humans began a relationship with the cosmos that continues to this day. These early sky observers, our distant ancestors, sought to understand the world around them, the cycle of day and night, the changing seasons, and the movement of celestial bodies. They watched, they learned, and they began to see patterns. Imagine, if you will, a group of ancient humans gathered around a fire, gazing up at the star-studded expanse of the night sky. They noticed clusters of stars that seemed to form shapes, and in their imagination, these shapes took on the forms of their gods and heroes. These patterns, these constellations, became their celestial guidebook, their stories written in the stars. From the vast plains of Greece to the river valleys of India, ancient civilizations observed the sky not merely as a canvas of twinkling lights, but as a complex system of celestial bodies. They proposed the existence of other worlds, a concept that was far ahead of its time. The Greeks, in particular, were instrumental in laying the foundations of astronomy, with philosophers like Anaximander suggesting that the Earth was not the center of the universe. Fast forward to the 17th century, a time of great advancements in lens technology that led to significant astronomical discoveries. In this era, the curtains of the cosmos were drawn back further than ever before, revealing the intricate ballet of celestial bodies in our solar system and beyond. Now let's talk about two pioneers who played pivotal roles in these revelations. First up is Christian Huygens. Huygens was a Dutch astronomer, mathematician, and physicist who in the mid-17th century made an observation that changed our understanding of the solar system. Using a telescope he designed himself, Huygens peered at the far reaches of the sky and found something extraordinary. He observed the rings of Saturn. This was a remarkable discovery, as it challenged the then prevailing belief that planets were simple, spherical bodies. Next, we move on to another Dutchman, Anton van Leeuwenhoek. While not an astronomer, his contributions were nonetheless monumental. Leeuwenhoek is best known as the father of microbiology. He improved upon the design of the microscope and was the first to observe and describe microorganisms, which he originally referred to as animalcules. Now you might wonder, what does this have to do with astronomy? Well, Leeuwenhoek's discovery of microbial life fundamentally shifted our perspective on life and its potential existence beyond Earth. If life could thrive in a droplet of water, who's to say it couldn't exist somewhere else in the vast expanse of the universe? These discoveries opened up a new world of possibilities, setting the stage for even greater astronomical achievements. The work of Huygens and Leeuwenhoek, among others, ignited a spark that would eventually burst into the flame of modern astronomy, forever changing our understanding of the cosmos and our place within it. As we move into the 19th century and beyond, we see the predictive power of astronomical observations come to life with the discovery of Neptune. This celestial body was not stumbled upon by chance, but rather found through mathematical predictions. It was a testament to the power of human intellect and the potential of astronomy. The location of Neptune was calculated based on irregularities in the orbit of Uranus, demonstrating that we could make accurate predictions about the universe based on careful observation and scientific principles. This predictive power wasn't just limited to the heavens. It was also a driving force behind earthly affairs, particularly those of global politics. The world was in the throes of the Second World War, a conflict that pushed technology to its limits. As the dust of war settled, two superpowers emerged on the global stage, the United States and the Soviet Union. The rivalry between them sparked a new kind of competition, a race not for land or resources, but for the stars themselves. The space race, as it came to be known, was a high-stakes game of technological one-upmanship. It was a race to prove who could reach further, go faster, and climb higher. It was a race for prestige, for scientific advancement, and for the very future of humanity. The space race was fueled by a combination of national pride, fear, and the tantalizing possibility of the unknown. The whole world watched as these two superpowers strove to outdo each other, their efforts culminating in remarkable achievements that would change the course of human history. The space race was not just about reaching the stars, it was about pushing the boundaries of what was humanly possible. It was about daring to dream, to explore, to discover. It was about the spirit of human curiosity and the relentless pursuit of knowledge. In the end, the space race was a testament to our innate desire to understand the world around us and our place within it. The stage was set for a race to the stars, a competition that would push the boundaries of human capabilities. Let's now delve into some of the significant milestones achieved during the space race. This period of intense competition and rapid innovation between the United States and the Soviet Union took us to new heights, quite literally. The Soviet Union, in a bid to establish its prowess, launched the first artificial satellite, Sputnik, into space in 1957. This metallic sphere, no bigger than a beach ball, was the harbinger of a new era, opening the gates to the exploration of the cosmos. But the Soviets were not done yet. In 1961, they sent the first human into space. Yuri Gagarin, a young pilot, became an overnight sensation, a symbol of human audacity and ambition. His journey, a single orbit around the Earth, lasted just 108 minutes, but its impact was timeless. And then there was Alexei Leonov, who in 1965 performed the first spacewalk. Free-floating in the vast expanse of space, tethered to his craft by a cord, Leonov experienced the cosmos in a way no human had before. On the other side of the globe, the United States was making strides of its own. The culmination of their efforts was the Apollo missions, a series of lunar explorations that forever imprinted human presence on the moon. In 1969, Neil Armstrong, followed by Buzz Aldrin, set foot on the lunar surface, marking a giant leap for mankind. These missions were not just about winning a race or showcasing technological superiority. They were about pushing the boundaries of what was possible, about reaching out to the unknown and making it known. They were about human curiosity, our innate desire to explore, to learn, to understand. These human missions were not just about winning a competition, but about expanding our knowledge and understanding of the universe. But space exploration didn't stop with human missions. Unmanned spacecraft have also made significant contributions. Our journey into the cosmos took a thrilling leap forward when we began sending unmanned spacecraft into the great beyond. Projects like Pioneer and Voyager have not only extended our reach into space, but also expanded our understanding of the universe. These unmanned missions have been instrumental in exploring regions of space that would be too risky or too distant for human travel. Take, for instance, the Pioneer missions. Launched in the 70s, Pioneer 10 and Pioneer 11 were our first emissaries to the outer planets. They provided invaluable data about Jupiter and Saturn, and Pioneer 10 went on to become the first human-made object to exit our solar system, a feat that symbolizes our inherent curiosity and our ever-burning desire to explore. Following pioneer steps, we launched the Voyager missions. Voyager 1 and Voyager 2 have been our eyes and ears in the outer reaches of the solar system and beyond. They've visited Jupiter, Saturn, Uranus, and Neptune, capturing stunning images and collecting data that have revolutionized our understanding of these distant worlds. And let's not forget the golden record aboard the Voyagers, a time capsule intended to communicate the story of our world to extraterrestrials. These missions have marked significant milestones in our cosmic journey. They've shown us that our solar system is but a tiny corner in the vast cosmic sea, and they've given us a sense of our place in the universe. The story of space exploration is a testament to our insatiable curiosity and our relentless pursuit of knowledge. It's a story of looking up at the stars and dreaming of what lies beyond. From the ancient sky observers to the modern explorers, we've come a long way, but the journey is far from over. From the ancient sky observers to modern explorers, our journey through the cosmos continues. Remember to subscribe and give a thumbs up if you enjoyed this trip. Hello, fellow science enthusiasts. Welcome to another exciting exploration into the unknown. Today, we delve into the promise and peril of space travel. Space travel. It's a concept that has captivated our collective imagination for centuries. It is a testament to our unquenchable thirst for knowledge and our insatiable curiosity about what lies beyond our planetary boundaries. The potential benefits are tantalizing: technological advancements that could revolutionize our way of life, increased human knowledge about the universe, and even the possibility of colonization of other worlds. Imagine a future where we have established sustainable colonies on Mars, where we have harnessed the power of the stars, and where we have gained a deeper understanding of our place in the cosmos. This is the promise of space travel, a future where the stars are not just points of light in the night sky, but destinations within our reach. But these dreams do not come without their share of nightmares. The journey to the stars is fraught with dangers that we are only beginning to understand. Catastrophic failures like the tragic loss of the space shuttles Challenger and Columbia remind us of the high stakes and the very real risk of loss of life. Moreover, the geopolitical tensions that can be aggravated by space travel cannot be overlooked. The space race of the mid-20th century was as much a demonstration of technological prowess as it was a battle for ideological supremacy. In an era where more nations and even private companies are reaching for the stars, these tensions could once again come to the fore. Then there are the technical challenges. How do we build reliable, safe, and efficient spacecraft? How do we protect astronauts from the dangers of radiation and the absence of gravity? How do we navigate through the thousands of pieces of space debris that currently orbit our planet? So, as we can see, the journey to the stars is fraught with both promise and peril. But what is holding us back from reaching out and touching the stars? The biggest hurdle to our cosmic aspirations is, quite simply, the astronomical cost. The expense of space travel is a mammoth one. And it's not just about building a spaceship that can break free from the Earth's gravitational pull. There's a whole laundry list of costs to consider. Let's start with the spacecraft. These aren't your everyday vehicles. They're complex machines, engineered to withstand the harsh conditions of space. The development and manufacturing of a spacecraft can reach into the billions of dollars. For instance, NASA's Orion spacecraft, designed to carry astronauts to destinations beyond low Earth orbit, has a development cost of around $16 billion. But the spacecraft is just the beginning. To launch it into space, you need a rocket, and those don't come cheap either. A single launch can cost anywhere from $50 million to hundreds of millions of dollars. And that's not even getting into the cost of the fuel, which can reach into the millions of dollars per launch. Then, there's the human element. Astronauts are some of the most highly trained individuals on the planet. Their training is rigorous and extensive, lasting several years and costing millions of dollars. And once they're in space, there's the cost of keeping them alive and healthy, which includes everything from food and water to medical supplies and exercise equipment. Let's not forget about mission support. Every space mission requires a team of scientists, engineers and other professionals on the ground to monitor and guide the astronauts. This support staff is essential and adds to the overall cost. All of these factors combine to create a price tag that can reach into the tens of billions of dollars for a single mission. Space travel is a costly endeavor, and these high costs have been a significant barrier to our exploration of the cosmos. But what if we could dramatically reduce these costs? Could an elevator to the stars be our ticket to the cosmos? Imagine boarding an elevator, pressing a button, and stepping out onto a platform overlooking the Earth from the edge of space. Quite an audacious idea, isn't it? This is the concept of a space elevator, a skyward escalator that could potentially revolutionize our approach to space travel. So, how does a space elevator work? At its simplest, it is a cable anchored to the Earth's surface, extending into space. This cable would be held taut by the centrifugal force of the Earth's rotation. The idea is to send payloads, and perhaps even humans, up this cable, using electrically powered climbers, much like an elevator car ascending a skyscraper, but on a much grander scale. The benefits of such a concept are numerous. Most notably, a space elevator could significantly reduce the cost of sending payloads to space. Today, it costs approximately $10,000 to send a pound of material into space using traditional rockets. With a space elevator, this cost could potentially be reduced to just a few $100s. Furthermore, a space elevator would open up space to a much broader range of participants. No longer would space be the exclusive domain of large, well-funded government agencies. Instead, universities, private companies, and even individuals could potentially have access to space, spurring innovation and accelerating our exploration of the cosmos. Nevertheless, the space elevator concept is not without its challenges. The primary obstacle is the lack of a material strong and light enough to construct the cable. Currently, the best candidate is carbon nanotubes, but we still lack the technology to manufacture them in the lengths required. Additionally, the elevator would need to be carefully engineered to withstand potential threats such as micrometeorites, space debris, and the harsh radiation environment of space. Though we are still far from realizing this audacious idea, it presents a tantalizing potential solution to one of space travel's biggest challenges. As we continue to push the boundaries of our technological capabilities, who knows what the future may hold? Perhaps one day, we'll all have the opportunity to press a button and ascend to the stars. But the cost is not the only challenge we face in our quest to conquer the cosmos. Indeed, the physical hazards of space travel are as daunting as the financial ones. Firstly, there's the issue of space debris. Imagine a tiny speck of paint traveling at speeds up to 17,000 miles per hour. Such a speck can penetrate the skin of a spacecraft, potentially causing catastrophic damage. Now consider that there are millions of such specks, along with defunct satellites and spent rocket stages, whizzing around in Earth's orbit. This is the perilous minefield that spacecraft have to navigate through. Next, there's the invisible enemy, space radiation. Far from the protective shield of Earth's atmosphere, astronauts are exposed to harmful cosmic rays. These rays can damage DNA, increasing the risk of cancer and other diseases. Lastly, let's not forget the toll that the absence of gravity takes on the human body. In microgravity, muscles and bones weaken, and the immune system doesn't function as it should. Astronauts have to exercise for at least 2 hours a day to counter these effects, but we're still learning about the long-term impacts. These are serious challenges indeed, yet they are not insurmountable. Scientists and engineers around the globe are working tirelessly to devise solutions, from developing advanced shielding methods to creating artificial gravity. These are serious challenges, but human ingenuity is already hard at work devising solutions. And while we work to overcome these challenges, we also dream of what the future of space travel might hold. As we look ahead, we see a future filled with potential, where space travel is not just a dream, but a reality within reach. We see a future where our technology pushes the boundaries of what we once thought impossible, and where the cosmos is no longer an unexplored frontier, but a familiar neighborhood. To make this future a reality, we need propulsion technologies that can take us farther and faster than ever before. One such technology is antimatter engines. Antimatter, the mirror image of matter, releases energy when it comes into contact with its counterpart. If harnessed, this energy could propel us at speeds that dwarf the capabilities of our current rockets. Imagine, if you will, a journey to Mars that takes weeks instead of months. But what if we could go even faster? This is where tachyon manipulation comes in. Tachyons are theoretical particles that move faster than light. While we haven't discovered them yet, if we do, and if we can harness their speed, we could traverse the cosmos in the blink of an eye. We could reach distant galaxies, explore other solar systems, and uncover secrets of the universe that have been hidden from us for millennia. Of course, these technologies are not without their challenges. Antimatter is difficult to produce and store, and the existence of tachyons is still a topic of debate among physicists. But, as we've seen throughout history, challenges are often the catalysts for innovation. They push us to think outside the box, to question the status quo, and to strive for a future that surpasses our wildest dreams. These technologies may seem like science fiction today, but who knows what tomorrow may bring. After all, the future belongs to those who dare to dream. The journey to the stars is no easy feat. It challenges us, pushes us, and demands the very best of us. We've faced the towering costs, the physical dangers, and the technological hurdles of space travel. We've examined the promise of space elevators and the potential of future propulsion technologies. All these elements shape our quest to the cosmos, a testament to human capacity and ingenuity. But as we stand on the precipice of a new era of exploration, we are reminded that the only limit to our reach is our own imagination. Until next time, keep looking up. Have you ever wondered how mankind first set foot on the moon? How did we go from launching rockets into the sky to landing a man on the lunar surface? It's a story of unprecedented ambition, a testament to the boundless reaches of human imagination and willpower, a tale that orbits around a singular, awe-inspiring mission, Apollo 11. This mission was the crowning glory of NASA's relentless efforts, fueled by a plethora of scientific and engineering advancements. It was a journey that spanned years of dedication and discovery, embodying the aspirations of a nation and the dreams of a world. But the story of Apollo 11 is not just about reaching for the stars, it's about the race to get there. In the mid-20th century, the world watched as two superpowers, the United States and the Soviet Union, engaged in a high-stakes race to conquer the cosmos. This space race sparked a period of accelerated innovation, pushing the boundaries of what was deemed possible. The Soviets had taken an early lead, stunning the world with their achievements. But in response, America launched the Apollo program, a spirited comeback that would eventually lead to one of the most monumental events in human history. The audacious commitment made by President Kennedy in 1961 served as the catalyst for this space exploration saga. Despite initial doubts and fears about the feasibility of landing a man on the moon, Kennedy's vision galvanized NASA to innovate at breakneck speed. It was a bold, audacious challenge, one that would inspire a nation and change the course of history. This mission was a stepping stone, an intermediate stage in the grand scheme of lunar exploration. Building on the successes and lessons of Project Gemini, NASA honed crucial techniques and technologies, such as rendezvous and docking procedures, setting the stage for the lunar landing. Despite facing technical challenges and setbacks, the tireless efforts of countless individuals, meticulous planning, innovative solutions, and unwavering public support propelled Apollo 11 to success. It was this mission that saw Neil Armstrong and Buzz Aldrin etch their names into history, becoming the first humans to walk on the moon. The Apollo 11 mission, then, was not just a daring adventure, but a testament to human ingenuity and determination. But how did we get there? It all began with the space race. The mid-20th century was a time of intense rivalry between two superpowers, the United States and the Soviet Union. This wasn't your typical competition. It was a race to the stars, a battle to prove technological and intellectual superiority on a stage that was as vast as it was unknown: space. The Soviet Union had the early lead, launching the first artificial satellite, Sputnik, in 1957, followed by the first human in space, Yuri Gagarin, in 1961. These triumphs were not just a matter of national pride. They were a demonstration of the Soviet Union's technological prowess, a direct challenge to the United States. In response, the United States refused to be left behind. The American answer to the Soviet Union's early achievements was the Apollo program, an ambitious project to land a man on the moon. It was a bold response, one that encapsulated the spirit of American determination and ingenuity. The Apollo program was more than just a mission. It was a symbol, a testament to the power of human curiosity and ambition. It was a rallying point for a nation, a goal that galvanized scientists, engineers, and the public alike. The space race was on, and the United States was determined to win. Yet the journey was not easy. There were doubts about the feasibility of landing a man on the moon. There were technical challenges to overcome, new technologies to develop, and new techniques to master. But the United States was undeterred. The nation embraced the challenge, driven by a desire to explore, to understand, and to prove that nothing was impossible. So, in the face of competition, in the midst of a grand space race, the United States dared to dream. They dared to look up at the moon and say, "We will be there." And with that daring dream, against this backdrop of competition and ambition, the Apollo program was born. In 1961, President Kennedy made a bold commitment. This commitment wasn't just any promise. It was a pledge that would ignite the spark of innovation, pushing the boundaries of what was deemed possible. In the face of skepticism and uncertainty, Kennedy proclaimed, "We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard." This audacious declaration set the stage for the Apollo program. Amid the tense atmosphere of the Cold War, Kennedy's speech served as a rallying cry, a mission statement for the United States, and indeed, for humanity itself. It was a commitment to reach beyond the familiar confines of our planet, to set foot on an alien world, to land a man on the moon. This was a goal that seemed almost insurmountable, a challenge that tested the limits of scientific and engineering capabilities. Yet it was precisely this bold commitment that spurred NASA to innovate at a dizzying pace. The feasibility of such a mission was initially met with doubt, even within NASA. The technological challenges were enormous, the risks significant, the unknowns countless. But with Kennedy's words echoing in their minds, NASA's scientists and engineers set to work, driven by a shared determination and a sense of purpose. Their efforts were nothing short of extraordinary. They developed pioneering technology, devised new methods, and pushed the envelope of what was scientifically possible. They were not just building a spacecraft. They were building a dream to step beyond our world and into the unknown. Navigating through the sea of challenges, they transformed Kennedy's bold vision into a tangible reality. The commitment to land a man on the moon was no longer just a lofty goal. It was a mission that would forever change the course of human history. With this audacious goal in mind, NASA embarked on a journey that would redefine the limits of human exploration. It was a journey that would lead to the triumph of Apollo 11, a triumph that would echo throughout the ages, a testament to the indomitable spirit of human curiosity and determination. Before Apollo, there was Project Gemini. This mission, often overshadowed by its lunar-bound successor, was nevertheless a vital stepping stone on the path to Apollo's success. Project Gemini was all about testing the waters, or rather, the vacuum of space. It was during this period that NASA refined and developed the techniques and technologies necessary for lunar missions. One such technique was the rendezvous procedure. The ability to join two spacecraft in orbit around Earth was a critical skill that needed to be honed. After all, Apollo's lunar module would have to reconnect with the command module after its lunar excursion, a maneuver that would be done in the moon's orbit. The Gemini missions provided the perfect training ground for this, with numerous rendezvous trials conducted between Gemini spacecraft and other objects in orbit. But rendezvous was just one piece of the puzzle. Docking was another crucial procedure that was refined during the Gemini missions. This involved physically connecting two spacecraft in orbit, a maneuver that would be necessary for transferring astronauts and equipment between modules on the Apollo missions. Gemini's docking procedures were tested extensively, laying the groundwork for the techniques used in Apollo. Beyond these technical feats, Project Gemini also served as a proving ground for the astronauts themselves. The Gemini missions allowed astronauts to practice working in the challenging environment of space, including conducting spacewalks, navigating, and even sleeping in zero gravity. These experiences would prove invaluable when it came time to journey to the moon. The Gemini missions were not without their challenges, of course. There were technical issues, risky maneuvers, and even a near-disastrous fire. But each hurdle overcome only further prepared NASA for the challenges that lay ahead in the Apollo program. Project Gemini, then, laid the groundwork for the historic journey that was to come. It was the stepping stone that bridged the gap between the dream of landing a man on the moon and the reality of that historic moment. Without Gemini, Apollo might never have left the launch pad. Finally, in 1969, the world watched in awe as Apollo 11 took flight. The journey to this momentous launch was far from smooth sailing. The Apollo program faced numerous technical challenges and setbacks. From the tragic Apollo 1 fire that claimed the lives of 3 astronauts, to the daunting task of building a spacecraft that could withstand the harsh conditions of space. Yet, it was through meticulous planning, innovative solutions, and an unwavering public support that these obstacles were overcome. Engineers and scientists worked tirelessly, pushing the boundaries of what was technologically possible. They designed and tested, failed and learned, and then designed and tested again until they had a spacecraft that was ready for the mission of a lifetime. Behind the scenes, the Apollo team was working around the clock, solving problems as they arose and making thousands of critical decisions. They worked with determination, fueled by a collective belief in the mission's success and underpinned by a nation's support. And then came the day. The day when all their hard work, all their sacrifices, and all their dreams were put to the ultimate test. On July 16, 1969, the Saturn V rocket carrying the Apollo 11 spacecraft lifted off from Kennedy Space Center in Florida. The journey to the moon was fraught with risks and uncertainties, but the crew of Apollo 11, Neil Armstrong, Buzz Aldrin, and Michael Collins, were prepared. They navigated through space, overcoming minor technical glitches until they finally reached their destination. On July 20, 1969, Neil Armstrong and Buzz Aldrin made history by landing and walking on the lunar surface. Armstrong's first step onto the lunar surface was broadcast live to a global audience. His famous words, "That's one small step for man, one giant leap for mankind," echoing around the world. To this day, the success of Apollo 11 stands as a testament to human ingenuity and determination. It was a journey that challenged our understanding of what was possible and pushed us to reach for the stars. And so, on July 20, 1969, mankind made its first steps on the moon, forever changing the course of human history. Have you ever wondered how the journey to understanding the cosmos began? Well, let's rewind to the mid-20th century. It's 1957, and the world is in the throes of the Cold War. A new frontier opens up, not on land, but in the vast expanse of space. The Soviet Union takes the first bold step in this new chapter of exploration, launching the first artificial satellite, Sputnik 1. Its beeping signal, audible on radios across the globe, heralds the dawn of the space age. This momentous event jolts the United States into action. The space race between these two superpowers is ignited, sparking a flurry of scientific and technological advancements. In response to Sputnik, the National Aeronautics and Space Administration, more commonly known as NASA, is formed in 1958. Its mission? To pioneer the future in space exploration, scientific discovery, and aeronautics research. NASA soon becomes the beacon of American space exploration. But it's not just about beating the Soviets. It's about pushing the boundaries of human knowledge and understanding. It's about exploring the unexplored, charting the uncharted and peering into the unknown. The space race propels humanity into a new era of discovery and innovation. Space exploration is not just a competition, it's a collaborative effort involving thousands of scientists, engineers, and astronauts. Each mission, each launch, each discovery is a testament to human ingenuity and perseverance. So, as we delve into the vastness of space, we are not just exploring distant planets and galaxies, we are exploring what it means to be human. From the launch of Sputnik 1 to the formation of NASA, these events lay the groundwork for the exploration of our solar system and beyond. The stakes are high, the challenges are immense, but the potential rewards, they're out of this world. The space race had indeed begun, setting the stage for a series of historic achievements. And that, my friends, is just the beginning. Indeed, the space race had begun, setting the stage for a series of historic achievements. Did you know the first successful mission to Mars happened in 1965? It's true. The Mariner 4, a spacecraft developed by NASA, changed the course of space exploration as we knew it. This historic mission was a part of the Mariner program, which was a series of robotic interplanetary probes launched by NASA between 1962 and 1973. The Mariner 4 mission was a grand achievement. It was the first to successfully fly by Mars and return close-up images of the Martian surface. These images shattered previous notions about our neighboring planet and provided a fresh perspective. They revealed a world not of canals and possible life, as some had speculated, but of a barren, moon-like surface. But the journey to Mars wasn't a standalone endeavor. The Mariner program was deeply rooted in the launch of Explorer 1 in 1958, America's first satellite. This marked the nation's entry into the space age, and it set the stage for further exploration, not only of Mars, but of other planets as well. The Mariner program was a pioneer in many ways. It was an integral part of NASA's consolidation of space exploration programs under a single civilian entity. This consolidation led to the development of sophisticated communication systems like the Deep Space Instrumentation Facility, which streamlined missions and enhanced efficiency. The Mariner missions didn't just explore Mars. They ventured to other planets too, like Mercury and Venus. They sought to understand the environments of these celestial bodies, their atmospheres, their magnetic fields, and their geological characteristics. This broadened our knowledge of the solar system and pushed the boundaries of what was deemed possible. The Mariner program was a testament to human ingenuity and the thirst for knowledge. It was a beacon of progress in a time of rapid technological advancement. It was a symbol of what we can achieve when we dare to dream beyond the confines of our own planet. The Mariner program truly marked a significant milestone in space exploration. It paved the way for future missions, future discoveries, and a better understanding of our place in the cosmos. It showed us that the sky is not the limit, but just the beginning. But what about our closest celestial neighbor, the Moon, you may ask? Well, the 60s were an exciting time for lunar exploration, thanks to NASA's Surveyor program. This ambitious undertaking aimed to achieve something never done before, a soft landing on the Moon. In the heat of the space race, achieving a successful lunar landing was crucial for demonstrating American capability in space exploration. The Surveyor program was a testament to American ingenuity, demonstrating that we could not only reach the Moon, but also land on it gently, without causing damage to the spacecraft. Launched in 1966, the first Surveyor spacecraft was a triumph of technology. It was equipped with a television camera and instruments to analyze the lunar surface. It was a real-life moon detective, if you will. As the Surveyor spacecraft descended towards the Moon, it sent back real-time footage of its descent, a first in the annals of space exploration. The world held its breath as the Surveyor touched down on the lunar surface, marking the first successful soft landing on the Moon by an American spacecraft. This feat was not just a show of technological prowess, but also a crucial stepping stone for future missions. The information gathered by the Surveyor spacecraft provided invaluable insights into the lunar surface. It was this data that helped scientists and engineers design the lunar module for the Apollo missions, ensuring that when humans finally set foot on the Moon, they would do so safely. The Surveyor program was more than just a series of successful missions. It was a statement of intent, a declaration to the world and to the cosmos that we were not just observers, but also participants in the great cosmic dance. In a sense, it was the dawn of a new era in space exploration, an era marked by curiosity, ambition, and a relentless drive to push the boundaries of what we thought was possible. With the successful lunar landing, the stage was set for the most ambitious mission yet. How much do we know about the outer planets in our solar system? In the late 1970s, a daring pair of spacecraft, the Voyager twins, embarked on a grand tour of the outer planets. This epic journey, a first in human history, was a testament to our insatiable curiosity about the universe we inhabit. The Voyager twins, Voyager 1 and Voyager 2, were a pair of robotic explorers designed to withstand the harsh conditions of space and the long journey to the outer planets. Powered by plutonium-238, these spacecraft were equipped to document everything they encountered on their journey. Their mission? To explore the outer planets, Jupiter, Saturn, Uranus, and Neptune. These planets, colossal gas giants and frozen ice giants, had always been enigmatic entities in our night sky. The Voyager's mission was to unravel their mysteries, to offer us a glimpse into their atmospheres, their moons, their rings, and their magnetic fields. The Voyager's journey to Jupiter, the largest planet in our solar system, offered us unprecedented views of its swirling storms and its many moons. Saturn, with its magnificent rings, was next. The images sent back by the Voyagers were nothing short of breathtaking. The journey continued to Uranus and Neptune, the ice giants. These planets, so far from the Sun, were like nothing we had seen before. The Voyagers revealed a world of blue-green hues, extreme winds, and peculiar moons. Throughout their journey, the Voyager twins collected invaluable data. They discovered new moons, explored planetary rings, and even found evidence of volcanic activity on Jupiter's moon Io, altering our understanding of where in the solar system life might be possible. The Voyager missions, this grand tour of the outer planets, expanded our knowledge of the solar system in ways we could never have imagined. They showed us that our solar system is a place of incredible diversity and beauty, and that our home, Earth, is just one small part of a much larger cosmic tapestry. The Voyager missions expanded our understanding of our place in the cosmos like never before. So how far have we come in our journey to understand the cosmos? The quest to unravel the mysteries of the universe has led humanity on a remarkable journey, marked by several significant milestones. It all began with the launch of Sputnik by the Soviet Union in 1957, the first artificial satellite to orbit the Earth. This event sparked a new era, the space age, and initiated the competitive yet collaborative spirit of space exploration that drives us even today. Following closely was the birth of NASA in 1958, a consolidation of America's space exploration programs under a single civilian entity. This brought about the launch of Explorer 1, the United States' first satellite, marking the beginning of the illustrious Mariner program. In 1965, Mariner 4's historic mission to Mars redefined our understanding of the Red Planet. It was a significant leap, not just for the Mariner program, but for all of humanity. This mission laid the foundation for further exploration of not only Mars, but also other planets like Mercury, Venus, and the outer planets. Then came the Surveyor program's successful soft landing on the Moon in 1966, a testament to American capability in space exploration. This was a crucial stepping stone for the subsequent Apollo missions, culminating in Neil Armstrong's iconic lunar landing in 1969. Fast forward to the late 70s, when the Voyager spacecraft embarked on a grand tour of the outer planets. These missions provided invaluable data and insights into planetary systems beyond Earth, broadening our vision of the cosmos. In the 21st century, the Mars rover missions have been a testament to our technological advancements, capturing the world's imagination and pushing the boundaries of what's possible. As we continue to reach for the stars, who knows what future milestones await us in the vast expanse of space? Have you ever wondered how space exploration found its way into our beloved video games? It's a fascinating journey that has its roots in the early days of gaming. Picture this. It's the late 70s. Arcades are all the rage, and a little game called Space Invaders is taking the world by storm. This was one of the first games to truly capture the excitement and wonder of space exploration. Space Invaders laid the groundwork for what was to come. It wasn't just about dodging alien fire and shooting back. It was about the fantasy of reaching out into the cosmos, the unknown. This game sparked a fascination in players that only grew as technology evolved. This was the dawn of space exploration games, a genre that would go on to inspire countless other titles. The arcade era was a time of rapid innovation in gaming. Developers saw the potential of space-themed games and ran with it. The excitement of technology and the future was captured in these early games. They tapped into our collective curiosity about the final frontier and gave us a glimpse of what might be out there. These games were not just popular, they were a phenomenon. They made their way from arcades to home PCs, reaching a wider audience and making gaming a mainstream pastime. The impact of these games on the industry cannot be overstated. They set the bar for what a game could be and paved the way for the immersive experiences we enjoy today. And so, from simple arcade games like Space Invaders, we witnessed an evolution towards more complex and immersive experiences. These early games set the stage for the future of space exploration in video games. They captured our imaginations and made us dream of exploring the stars. They showed us that the sky is not the limit, but just the beginning. From simple arcade games, we witnessed an evolution towards more complex and immersive experiences, setting the stage for the future of space exploration in video games. As technology advanced, so did the complexity and depth of space exploration games. The 90s were an era of innovation, a time when the digital world began to stretch its wings. Among the many marvels of this decade, space exploration games began to evolve, pushing the boundaries and expectations of what was achievable within the realm of video games. In this transformative era, two games stood out particularly: Wing Commander Privateer and Frontier Elite 2. These weren't just games, they were expansive universes, offering players an unprecedented level of freedom and immersion. Wing Commander Privateer, for instance, gifted gamers with a sprawling universe teeming with planets, star bases, and alien species. You could become a law-abiding merchant, a ruthless pirate, or a daring bounty hunter. The choice was yours, and every decision you made had tangible consequences. The game was a symphony of intricate mechanics, rich storytelling, and groundbreaking graphics, all wrapped up in a universe that felt alive. On the other hand, Frontier Elite 2 took space exploration to a whole new level. This game was a pioneer of procedural generation, creating an entire galaxy from mathematical algorithms filled with billions of stars and planets to explore. It was an open-ended game where you could trade, fight, and explore, all at your own pace. It was so detailed that it even had a realistic model of the Milky Way galaxy, and each star system had its own unique economic and political system. These games weren't just about blasting aliens or collecting resources. They were about exploring the unknown, making choices, and living with the consequences. They pushed the boundaries of what was possible, not just in terms of technology, but in terms of storytelling and player agency. In essence, Wing Commander Privateer and Frontier Elite 2 brought to life the captivating allure of space exploration, the thrill of discovery, and the joy of charting your own path. They offered an escape into a vast universe right at your fingertips. The 90s truly revolutionized space exploration games, paving the way for the games we know and love today. Fast forward to the present day, and space exploration games have taken a quantum leap forward. We're now living in an era where the line between reality and virtual reality blurs, thanks to the incredibly immersive and expansive experiences offered by modern space exploration games. Take, for instance, Kerbal Space Program. This game is not just about exploring space, it's about understanding the complex principles of astrophysics and rocket science. Players are challenged to build their own spacecraft, manage their crew of Kerbals, and explore the cosmos, all the while adhering to the laws of physics. It's a game that marries fun with education, making the vast expanse of space a little more accessible to us Earthlings. Then there's Elite Dangerous, a game that pushes the boundaries of exploration and discovery. Here, you're not confined to a predetermined path. Instead, you're free to traverse a stunningly realistic, procedurally generated galaxy based on real-world astronomical data. Whether you choose to be a trader, a pirate, or an explorer, the choice is yours, and the universe is your playground. And let's not forget Starfield, the latest offering from Bethesda Game Studios. It's a single-player game set in space where you, the player, are at the heart of an epic adventure. The game promises a level of detail and scale that we've never seen before in this genre. It's not just a game, it's a testament to how far we've come in the realm of space exploration games. But it's not just about the games themselves. It's about the communities they foster, the discussions they spark, and the inspiration they provide. These games are more than mere entertainment. They're platforms for learning, for creativity, and for a shared love of the cosmos. Today, space exploration games are more popular than ever, offering endless hours of exploration and discovery. It's a golden age for fans of the genre, and it's exciting to think about what the future might hold. Creating a space exploration game is no easy task. Let's delve into some of the challenges developers face. Crafting these expansive virtual universes is a feat of both creative and technical prowess. One of the primary challenges is balancing procedural generation with maintaining immersion. Procedural generation, for those unfamiliar, is a method in game development where a large amount of content is generated algorithmically rather than manually. This allows developers to create vast, seemingly infinite universes for players to explore. The problem arises, however, when this vastness becomes overwhelming, or worse, feels empty or repetitive, breaking the player's immersion in the game world. Let's take No Man's Sky as an example. Its universe is composed of over 18 quintillion planets, each procedurally generated. While this is an impressive feat from a technical standpoint, it led to some criticism at launch. Players found that many planets felt similar, and the vastness of the game world often felt empty and devoid of meaningful content. Similarly, Elite Dangerous, another popular space exploration game, uses procedural generation to create a one-scale model of the Milky Way galaxy. While this provides a stunning backdrop for space exploration, it also poses the same challenges. Balancing the procedural generation of such a vast universe with the need to maintain player immersion and deliver on player expectations is a tricky task. Beyond procedural generation, there are other challenges too. Crafting compelling narratives, designing engaging gameplay mechanics, and creating believable alien species and ecosystems are all part of the complex process of developing a space exploration game. Despite these challenges, developers continue to push the boundaries, creating ever more immersive and expansive space exploration games. The lessons learned from past endeavors fuel the innovations of the future, pushing the genre forward and continually redefining our expectations of what a space exploration game can be. Space exploration games have come a long way since the days of Space Invaders. From the simplistic, pixelated aliens of early arcade games to the breathtaking, fully realized universes of modern masterpieces, the genre has evolved in leaps and bounds, mirroring our own advancements in technology and our ever-growing understanding of the cosmos. In the early days, games like Space Invaders and Star Trek tapped into the excitement surrounding technology and the future, offering players a chance to boldly go where no gamer had gone before. They were simple, yes, but they sparked a fascination and love for the unknown, a fascination that would only grow as technology advanced. The 90s saw a revolution in the genre, with games like Wing Commander Privateer and Frontier Elite, two offering open-ended experiences and impressive scale. These titles weren't just about blasting aliens or dodging asteroids. They were about exploration, about carving your own path in a vast, uncaring universe. They were about freedom. In recent years, we've seen a resurgence in space exploration games. Titles like Kerbal Space Program, Elite Dangerous, and Starfield have generated significant interest, offering players the chance to explore and shape their own galaxies. These games have pushed the boundaries of what's possible, offering procedurally generated universes that promise infinite possibilities. Yet, with great ambition come great challenges. Balancing procedural generation with maintaining immersion and delivering on player expectations is no easy task, as games like No Man's Sky and Elite Dangerous have shown. Yet even in failure, there's a lesson to be learned, a stepping stone to something greater. As we look to the future, one thing is clear: the sky's no longer the limit for space exploration games. The genre has proven itself capable of evolving, of pushing boundaries, of reaching for the stars. And who knows, maybe one day we'll be playing these games not from our living rooms, but from a colony on Mars, looking out at the stars we once only dreamed of reaching.